All right, lesson 4, we're going to do some application problems. We're going to just deal with one on this lesson. You get to practice on some more. But we're going to talk about a flare is fired upward from the deck of a ship. The flare hits water. The height of the flare h meters above the water after t seconds is given by the function h equals negative 4.9 t squared plus 98t plus 8. So we're asked to find all the key features of this particular parabola. We're going to cheat for a couple of minutes and look at a graphing calculator. And then we're going to make sure we could get to the same place all by ourselves. So let's have a look at a graphing calculator. Right, so we're going to type in our equation into our graphing calculator. First of all, we have negative 4.9 t squared, so I need the negative down at the bottom of the calculator. It's a little bit smaller than the subtract sign. We haven't got a t as an option here, so I've got to use x squared plus 98x, in this case, plus 8. So I need to think logically about whether I could see this on a grid or not. The numbers are pretty big. That 98's making me a little suspicious, but I know my y-intercept is 8. I also know it opens upside down. So I'm going to look at my windows, and I think, well, negative time is just silly, so I'm going to change that to just negative 2, just so that I can see my y-axis. I think 10 seconds would make sense for a flare to be in the air. I don't know. My Y max, I'm a little suspicious, should be a little bit bigger though. I think flares could go pretty high. I'm just randomly choosing the number 50, but I think I need a large Y max value. Let's see what we see. Okay. I can only see that y-intercept of 8. I need a lot bigger y-max. So let's go back and have a lot bigger number. And let's also have more time, because I didn't see where the parabola came down. So I'm just increasing my numbers and see if I can see it a little bit better. There. I still need a higher y max. So this flare goes pretty high. I'm going to triple it, because I don't actually know what the vertex is. Well, that's certainly a better view. Let's keep going here. There. So I have a picture of my graph, and my questions that have been asked are, determine the maximum height of the flare. So to find key features of a parabola, I go up above the trace button where it says calc. So second value trace, there's my calc. I want the maximum value. And with our graphing calculator, I have to go to the left of the maximum and to the right, so it knows where it's looking for the highest value. There, I can definitely see it's to the left of the max there. Scrolling. There, definitely to the right. Hit enter again. There. The very maximum value is 10,498. So I'm going to record that. The vertex is 10,498. Okay. The next thing it asks us is, how long does it take the flare to reach its maximum height? Well, that's also part of the vertex, apparently 10 seconds to reach its maximum height. C, when does the flare hit the water? I want to know an x-intercept for that. I don't care about the x-intercept that would be a negative one, because that wouldn't make sense in the context of the problem. I want to know the x-intercept down here. And so I'm going to do the second function trace again and look for a 0. Other words I could look for were x-intercept or roots, but the graphing calculator chooses 0. So I want to go and tell it to look at that root. That's way over here. There it comes. Okay, I'm going to put a marker there, because that's definitely to the left of the x-intercept that I'm looking for. Keep scrolling right. See, my y values are now going negative, so I must be past that x-intercept, so I'm going to hit enter there. My two markers show me to look between here and here. Enter again. And it says my one x-intercept is 20 and a bit. So approximately 20. And it says the flare would hit the water after 20 seconds. Lastly, it says how high is the deck of the ship? We would be looking for the y-intercept. And the y-intercept would be on the y-axis. So I'm going to do second function trace, and I'm going to put a value in for x. So option number 1 says value, and I want to say x equals 0. And that answer should be 8. And we knew that because we had the equation in standard form. That gives us the y-intercept. So according to our graphing calculator, these are the things that we're looking at. Let's draw a rough sketch, very rough sketch. So we have a y-intercept of 8. We have an x-intercept of 20. And we have a highest value in the middle, which is at 498. So no scale, but just a really rough idea. What we were looking at on the graphing calculator was this. Doesn't make sense when you go negative, so we would really stop it at that x-axis. What if we were stranded on a desert island and wanted to find out this information and didn't have a graphing calculator? Can we deal with that equation on our own? So let's try it. H equals negative 4.9 t squared. Let's write it down here. Plus 98t. That's got a good velocity, doesn't it? Plus 8. So that plus 8, I assume, is the height of the ship above the water, which kind of makes sense. And we are first of all asked about the vertex. So A and B we can answer from the vertex. If I want the vertex, I really want vertex form. That means I need to complete the square. Okay, here we go. If I want to complete the square, I want to deal with that 4.9 first of all, and then I'll complete the square on what's left. So if I factor out a 4.9 from the first term, there, I'm left with t squared, which is awesome. If I factor out 4.9 from the second term, negative 4.9, sorry, I need a negative in the bracket, and I have to figure out what 98 divided by 4.9 is. Well, nicely, it's 20. Coincidence? I think not. Okay, I am leaving my 8 out for later because 4.9 does not divide into 8 nicely. So I'm going to deal with it later like we did on some yesterday or the day before, whatever. If I'm going to complete the square, I am going to skip a line and show the perfect square that I'm aiming for, which is always half of that middle term. So it would be negative 10. If I want to have t minus 10 squared, I'm going to go back up to the line before and introduce a number, both adding it and subtracting it to the equation, and that number would be 100. 10 squared. Don't forget the plus 8. Okay. In the brackets, the t squared, subtract 20t plus 100. Give me that beautiful square. I still have the negative 100, and it's still in brackets. Don't forget the plus 8. Almost there. H equals negative 4.9. I'm going to do distributive law, so I don't have that extra set of brackets. T subtract 10 squared. If I do distributive law and I multiply negative 4.9 by negative 100, I get positive 490. Don't forget to add the 8. One last line. I can put the two numbers together. Negative 4.9, t subtract 10 squared plus 498. What do you know? The vertex is 10 to the right, 498 up. So when it asks us, what is the maximum height? The maximum height of the flare is 498 meters. And that happens 10 seconds after it's let go on the ship. That answers A and B. So 10 seconds, 498 meters. Okay. When does the flare hit the water? According to the graphing calculator, it was 20 and a bit seconds later. So how would we figure that out? If this equation isn't nicely factorable, if I have it in vertex form and standard form, but not nicely in factored form, then I am trying to find x-intercepts by using other strategies. Last day we looked at the quadratic formula. So to find an x-intercept, I can use this formula. X equals negative b plus or minus b squared minus 4ac over 2a. And we're going to need a calculator handy to do so. So I'm going to be scrolling up to the original equation to make sure I get my numbers correct. But my a value is the number in front of the t squared term. B is the t term, and c is the numeric term. So when I do b squared, I have got negative 98 plus or minus, oh my, 98 squared, subtract 4 times negative 4.9 times, sorry, that square root sign should have been a lot longer. The c term was, 8, yes. 8 all over 2 times negative 4.9. So now we need to be careful and we need to have a calculator handy, but this should give us an answer, two answers in fact, one that's just silly and one that's close to 20. So the first thing I need to do is find out what 98 squared is. It is 9,604. Then I'm going to subtract 4 times negative 4.9 times 8. So the first thing I noticed is that I have two negatives. So I'm going to have a positive. I'm going to type into my calculator 4 times 4.9 times 8, and I get 156.8 all over. 2 times 4.9 negative is negative 9.8. All right. Negative 98, add or subtract. 156.8 and 9,604 is 9,760.8. Over negative 9.8. Almost there. The square root of that number is 98.796. Okay. Negative 98. Add or subtract approximately 98.8 over negative 9.8. You ready? We have two answers. X equals negative 98. Add 98.8 over negative 9.8. Or my other answer is x equals negative 98. Subtract 98.8 over negative 9.8. Let's do this thing. Okay, on the top, I have negative 98 plus 98.8 is 0.8 divided by negative 9.8 is negative decimal 0.8. That one doesn't make sense in terms of the problem. Doesn't fit the problem. Okay? because this story started on the boat at time 0. So having a time value or an x value of a negative doesn't make sense. I should have been using t instead of x, shouldn't I? Yeah, I should have been using t. I'm sorry. T, 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 time. Okay. The second one, we think it's supposed to be close to 20, but let's check. If I have negative 98 and I subtract 98.8, I get negative 196.8 divided by negative 9.8, 20.08 or 20.1. 20.1 seconds is when it hits the water. And lastly, it says, how high is the deck of the ship? Well, that we don't have any work to do. That comes from standard form, which we were given at the beginning. So the deck of the ship is 8 meters high.